Hello, we are in Chapter 7, Section 7.3, Exponential Functions. In this video, we're going to go over an example of graphing exponential function. The base of the exponential function we are to graph is 1/2, and we will first fill in the table of values. Let's start with the exponent of 0, since we know that any non-zero number raised to the power of 0 is equal to 1. And that will give us the point 0, 1. Next, we evaluate at 1, since anything raised to the power of 1 is the thing itself, so it's going to give us 1/2, and the point 1, 1/2 on the graph. Then when we evaluate at 2, it's going to be 1/2 squared. And when we square a fraction, then we apply the exponent to both the numerator and denominator. So 1 squared is 1 and 2 squared is 4th. So 2, 1/4 is another point on the graph. And when we raise to the power of 3, we're going to have 1/2 raised to the power of 3. So again, we apply that external exponent to both the numerator and denominator to obtain 1 to the power of 3, which is just 1, over 2 to the power of 3, which is 8. So our fourth point on the graph will be 3, 1/8. Now let's turn to those negative exponents. Let's start with 1/2 to the power of -1. Now we recall that negative in the exponent means reciprocate and change the exponent to opposites. So we can reciprocate that base of 1/2 to get 2 over 1, which is simply 2, to the power of the opposite of -1, which is +1, and 2 to the power of 1 is just 2, resulting in another point on the graph, -1, 2. And then similarly, raising 1/2 to the power of -2 will be the same as raising 2 to the power of 2, which is 4, resulting in the point -2, 4, and raising 1/2 to the power of -3 results in 2 to the power of +3, which is 8, resulting in another point on the graph, -3, 8. We have enough points on the graph to join them with a nice smooth curve that extends in both directions, obviously. And now we can identify the domain of this function. Well, as every exponential function, actually, the domain is all real numbers, since we don't have to exclude anything. We don't have any domain constraints in here. The range is determined vertically by looking at the values of our function. As you can see, the values start at 0, but never reaching 0, actually, and they go up to +infinity. So it will be an open interval from 0 to infinity. And finally, the horizontal asymptote. As you can see here, it looks like the graph is hovering over the x-axis, never reaching it. So the x-axis, that means the line y equals 0, is the horizontal asymptote. And that's how we can approach graphing exponential functions and identifying their properties.